All right, hello there. So if you missed class today, or if you just want to look back, this is from September 7th, and we're very first section of geometry, talking about nets and other visual drawings for geometry. Because this is the intro to geometry, and we need to understand that a lot of this is visual. So there's different drawings that we're going to be able to see, and I want to focus on three of them today. So the first one to look at is a net. Now, um, a net is a two-dimensional diagram that you can fold to form a three-dimensional figure. Now, if you look on the bottom, it kind of looks like a cross, just on its side. It doesn't have to be on its side. But the fact of the matter is it's two-dimensional. That's the first thing. But we're representing a three-dimensional figure. So what I can show you here is that these four pieces are going to be four sides when they fold over. You could call that the whatever side, whichever way you're looking at it. I'm going to erase that just real quick. So I'm going to do that. If you were to fold that, let's say this is A, B, C, D, E, and F. You fold A over, it's going to end up being opposite of C. B is going to be end up being opposite of D when you fold them up. And then you fold up the E and F to connect it into a square. It's going to be a perfect square. You notice that they're all the same sides, or it's not going to be a square, it's going to be a cube. It's made up of 2D squares. There's other ways that you could draw it, and I'm just going to draw one right here. So if you draw it now, mark, just pretend that these are all the same. These are actually all perfect squares. We're going to clone that a few times. And one more. And when I drag them next to each other, I still want four next to each other like this. So it's going to fold to make that thing. But if I wanted to, I could put this here, and I could put this here. Because when they fold over, they're still going to make that perfect square. I could put these across from each other here. I could put two on the ends, or each of the sides on the ends, like so. And if you fold it over, it's still going to make that 3D shape, which is a cube. Now the benefits of this, and I'm not going to write them all out, but some of the benefits, and we wanted to look at why nets are so awesome. It's 2D first of all. You don't have to worry about 3D. All right. Second of all, it shows the surface, all the surfaces. So you can look at surface area. That's great. The surfaces are all shown. Some cons might be, well, it's not in 3D. It's not the actual 3D object. And it might be hard to visualize. Just saying, as if I'm trying to put it back into its cube, that might be hard to visualize and hard to do. So that could be a con. But nets are still very useful. The second thing I wanted to look at here is a isometric drawing. An isometric drawing is a corner view of a drawing in a three-dimensional drawing. Again, it's 2D, but it shows the top, as you can see here. The top. We'll put a. I will color that blue. You can see the tops here. You can see the front, and this would all be on the front. And you can also see one side. So typically it's the right side. That's going to be right here and right here. If you look at it in the 3D view, but this is really just a 2D picture of it, which is pretty neat. And usually they're on isometric paper. So if you were to draw that out, you first want to draw the edges that surround the front. So I'm going to try this right here. I'm going to start, I'm going to say, this is going to go from, we'll start it, say right here. We're going to go 1, 2, 3, and then up 1, over 2, looks like that goes up, and over, and there's the front. That's the front edge. The next thing you want to do is start at all those vertexes and draw the edges to the right. So we've got to the right here, we've got to the right here, and the only lines you draw when you're drawing an isometric image is just where it would fold. So right here it's going to fold, and I'll put in blue where it doesn't fold, because there's a line here in the picture before, but it actually doesn't fold there, so we don't need that there. Going back to the green, the top goes all the way over here and all the way over here. Those all fold. And then the last thing you need to do is draw the back and the top edges to connect the figure. So it's kind of bringing it all together. And you draw parallel edges as well. So if I'm looking here, this is going to go all the way down. Now you can't see the bottom, but that's kind of where it ends. It's the last part that we can see. We're going to connect it here, which is parallel to here. This right here is actually folded over there. And these are all the parallel edges as well. And I believe I have the whole figure there. And again, the reason why we don't put this here and this here is because those are not folded edges. Or same thing goes with all of these other blue marks. They're not folded, so we don't have to worry about them. But that does complete the isometric image using isometric paper. If you want to look at this, a couple pros, again, are it's 2D. It's nice to see in 2D, and it looks like it's in 3D, but it's actually just on a 2D paper. Cons, you can't see everything. Like I mentioned, you can't see the back. So that makes it hard to find, surface area, see where everything actually is in the back. And those are the main things with isometric. But now the last one that I wanted to show you is it's called a orthographic. An orthographic drawing is another way to represent a three-dimensional figure by showing three separate views of the top, front, and right side. So really, if we're looking at this looks like a 3D picture. We're just going to make it so that you can see the top, the front, and the right sides, because that's what an orthographic one is. And this is probably what you'd use the least amount to do in 2D, but it doesn't really matter. The fact of the matter is we're gonna try it anyway, because you will see these. So if you draw the top, if you imagine you're looking from the top, I would imagine looking from the top, and all I would see is, I'll actually make these good cubes this time. I would see that. And I'm going to copy that a few times. I'm going to do it a whole bunch of times, actually. Actually, if I connect those, so I would see this, and again, I'm turning it a little bit. But this is kind of what it would look like from the top. And that's all you need for that. I'm going to clone some more so I can do the other parts. Now you need the front view. And you can see the front view really well. It basically looks like this. You can see that on top of that. One here, one there. And it looks like you'd be able to see this as well. Alright, so that's the front view. Now all you need left is the right view. Sorry about that. And I'm going to need 3, I believe. If you look at the right, it's probably all you can see is this, and that. Now the tough thing about the orthographic views is it's not very easy to reconstruct given those things, put it into an isometric. It's really hard to do. And And it also doesn't show all the sides. Does not show all the parts. Kind of like the isometric, you can't see all the parts. One nice thing about it is you do see some of the surface area. Again, it's 2D, and you can see some of the surface area. But again, you can't see all of it. So this is again, it's not one of the most used types of drawings, but it is used, and it's part of geometry. So I wanted you to see this as well. You see some surface area, or surfaces. But those are the basic three that we're talking about here. The orthographic, again, the isometric. This is the orthographic. The isometric, which it gives you a corner view. And you can kind of see it in 3D. It looks like it's 3D here. But it's really just a corner view of it. And then back to the nets, which you have probably done already. And there's lots of different ways to draw nets, but the nets is showing all the surfaces. And then how you can fold it back together to get to your original figure. Other than that, that is the basics of section 1.1 on nets and other drawings. So have a great rest of your day.